Why do people spend $30,000 on a used BMW and then drop another $15,000 fixing it in year one? Why does the same company that built one of the greatest engines in automotive history also build one that destroys itself with zero warning? And how do you actually know which one you're getting before you hand over the money? That's what this video is. 6 BMW engines ranked best to worst. What makes each one great, or what makes it expensive? What actually goes wrong, and what doesn't? Let's go. We start with the S54, and if you know BMW engines, you already know why this one goes first. Naturally aspirated inline-six, 8,000 RPM redline. No turbo, no forced induction, nothing artificial pushing the power, just displacement, compression, and engineering. BMW built this engine specifically for the E46 M3, and the difference between this and everything else they made at the time is significant. Here's what most people don't know. The S54 shares its basic architecture with BMW's regular production inline-sixes from that era, the M52, the M54. Same block family, same general layout, but every single internal component was redesigned from scratch. Different pistons with higher compression ratios, different connecting rods built for higher RPM loads, different camshaft profiles on both intake and exhaust, individual throttle bodies instead of a single intake manifold. BMW didn't take a normal engine and tune it up. They used the same bones and rebuilt everything inside around a completely different purpose. The result is an engine that does something most engines don't. It pulls hard through the entire rev range, not just at the top where high-revving engines usually come alive. From 3,000 all the way to 8,000, the power delivery is linear and consistent. That's genuinely difficult to achieve, and it's why people who drive E46 M3s talk about the S54 the way they do.
Now, one real issue, and you need to know this before you buy, the rod bearings wear faster than they should. This is a documented problem. BMW knows about it, the community has known about it for years. What happens is the bearing clearances are tight from the factory, and under hard use, or even just age and heat cycles, they wear down to the point where you lose oil pressure to the rods, and if you miss it, it becomes a catastrophic failure. But here's the part most people leave out. Fixing it proactively costs around $400 in parts. It's a weekend job if you have mechanical ability, or a straightforward shop job if you don't. You do it once, before there's a problem, and the engine is effectively sorted. The people who get hurt are the ones who buy the car, skip the bearing inspection, run it hard, and find out at highway speed. Do the bearings, maintain the oil, and the S54 will outlast the rest of the car. That's the whole ownership story. The M54 is the engine that actually built BMW's reputation for inline-six refinement, and it did it by being the opposite of complicated. No direct injection, no turbocharger, no complex systems layered on top of each other trying to extract extra performance. Vanos variable valve timing on both intake and exhaust, a solid forged bottom end, and that's largely it. The architecture is clean, the components are proven, and the result is an engine that people run past 250,000 miles without major work, not because they got lucky, but because there's genuinely less to fail. Think about what that means in a used car context. Every additional system on an engine is something that can wear out, leak, or break. Direct injection engines deal with carbon buildup on intake valves. Turbocharged engines deal with seals, boost leaks, heat soak, and oil consumption. The M54 has none of that. It's a naturally aspirated engine with conventional port injection and one variable timing system. The engineering is sound, and the failure modes are well understood. Here's what you stay ahead of on an M54. The cooling system components, thermostat, water pump, expansion tank, are plastic, and they have a service life. Around 100,000 miles, they start to age, and when they fail completely. The expansion tank cracks, the thermostat sticks, the water pump impeller separates. None of these are expensive parts. The problem is when people ignore them and end up with an overheating engine. Replace the full cooling system as a set, all three components before they become a problem, and you're done. The Vanos seals are the other item. Over time, the rubber hardens, the seals lose their ability to hold pressure, and you get a rough idle and noticeable power loss at low RPM. Again, not an expensive fix and completely predictable. A Vanos rebuild kit costs very little, and the job is straightforward.
Outside of those two things, the M54's ownership experience is close to nothing. It's not the exciting engine, it doesn't rev to 8,000, it doesn't have the motorsport heritage, but if your priority is a BMW that drives beautifully, costs almost nothing to maintain, and doesn't generate surprises, the M54 is the answer. The N54 is where BMW's story gets complicated, because this engine is genuinely impressive and genuinely difficult to own at the same time, and both of those things are completely true. It was BMW's first mass-market twin-turbo engine, 2 small turbochargers instead of 1 large one, the idea being faster spool-up and a broader power band. 300 horsepower from the factory in 2006 was a serious number, and the tuning community figured out almost immediately that the engine had enormous headroom. A software tune alone, no hardware changes, no mechanical modifications, pushed output to around 400 horsepower. The internals handled it. That's not common. Most factory engines don't have that kind of margin built in, and the N54 did. So the performance case is real. Now here's the honest ownership picture. The high-pressure fuel pump. This is the first thing that goes on basically every N54, and it's not an if, it's a when. The HPFP fails and the car goes into limp mode. BMW actually extended the warranty on this part after enough failures piled up. If you're buying an N54 car and it hasn't had the HPFP replaced, budget for it. The wastegate actuators. The turbos develop a rattle at cold start, a chattering noise that BMW eventually addressed with an updated part. It's not immediately damaging, but it gets worse over time, and the updated actuators are the fix. The charge pipes. The boost pipes connecting the turbos to the intercooler are plastic from the factory. Under boost pressure, particularly on tuned cars, they split. This is a known failure. Upgraded silicone charge pipes are a standard N54 modification and cost around $100. Should have been the factory spec. Injector wear. The high-pressure direct injection system puts significant stress on the injectors, and they wear out over time. Rough idle, misfires, hard starts, usually injectors. Replacing all 6 at once is the right call when you start seeing symptoms. Oil leaks from the valve cover gasket and the oil filter gasket are guaranteed on a high-mileage N54. Not catastrophic, just expected maintenance. Here's how to think about the N54. Every single one of those issues is fixable. None of them kill the engine. The problem is when someone buys an N54 car at what feels like a good price without accounting for the deferred maintenance that almost certainly exists. If you price the car knowing you might be spending $1,000 or $1,500 on catch-up repairs, the N54 is one of the most enjoyable engines BMW has ever produced. If you expect it to just run, it'll frustrate you. Know what it is, price accordingly, stay on top of it. The B58 is what you get when BMW spends a decade learning from the N54 in the N59 and actually applies those lessons. Single twin-scroll turbocharger instead of 2 separate turbos, which immediately simplifies the system. Fewer components, fewer connections, fewer things to leak or fail. The turbo sits in a better position thermally than the N54 setup. The oil system was redesigned with larger passages to improve lubrication under load, and the charge cooling system is water to air instead of air to air, which is more efficient and more consistent. The result, 340 horsepower stock, and like the N54, the reliability record is substantially cleaner. The B58 doesn't have the same list of known weak points following it around. It's a modern, complex turbocharged engine, so it has maintenance requirements, but the chronic failure patterns that defined N54 ownership are simply not present in the same way. The tuning headroom is remarkable. The engine community has documented B58s running 500 horsepower on completely stock internal components with appropriate supporting modifications. The bottom end, rods, crank, pistons, is built with enough margin that it handles power levels well above factory output without failure. BMW over-engineered the internals in a way they didn't on some previous platforms. Known issues are minor. Some early production B58s had a charge pipe that could crack under sustained boost, the same basic problem as the N54, just smaller scale. BMW updated the part, and aftermarket options are widely available. Outside of that, B58 ownership at stock power levels is largely maintenance-driven. Oil changes, cooling system attention at higher mileage, spark plugs on schedule. If you're shopping for a newer BMW and trying to figure out what engine is under the hood, the B58 is what you want to see. It's the engine where BMW got the formula right. If you've watched this far, you're doing real research before buying, which is exactly what this channel is built for. Hit subscribe so you catch the next video. We go deep on specific models, specific years, what to look for before you buy, what questions to ask a private seller, all of it. Now, back to the list, and from here it gets worse. The N63 is where BMW's engineering ambition created a problem they couldn't solve fully, and the people who paid for it were the customers. Here's the detail that explains everything. On most turbocharged engines, the turbochargers are mounted on the outside of the engine, bolted to the exhaust manifolds on either side, exposed to airflow, able to shed heat. On the N63, BMW did something different. They mounted both turbochargers in the valley, the space between the two cylinder banks, right in the center of the engine. The engineering reasoning was sound. Shorter exhaust path from the cylinders to the turbos means less turbo choke, faster spool, better response, and the engine is genuinely fast. The performance numbers are real. The problem is thermal management. Two turbos operating at high temperature, sitting in an enclosed space between the cylinder banks with limited airflow and nowhere for the heat to dissipate. That heat saturates the surrounding components, and the first thing to suffer are the valve stem seals. These are the seals that prevent oil from entering the combustion chamber through the valve guides. When they fail, oil gets into the combustion process and burns. What this produces is an engine that consumes oil not from a leak you can see on the ground, but from combustion. You check your oil, it's low. You top it off. A few weeks later, it's low again. No visible leak, no smoke in most cases, just oil disappearing. BMW's stated acceptable oil consumption rate for the N63 was 1 quart every 750 miles. That's the number BMW published is within specification. For context, a healthy modern engine should consume essentially no oil between changes. An engine consuming a quart every 750 miles has a problem. BMW called it normal. The repair, when the valve stem seals finally need replacing, is a major job on this engine, specifically because of where the turbos are. Everything that makes the N63 perform well also makes it difficult to work on. Accessing the components in the valley requires significant disassembly. The labor hours are substantial, and the cost reflects that. BMW ran a customer satisfaction program covering some of the repairs on certain model year vehicles. It helped some owners. The underlying design, turbos in the valley, heat buildup, seal degradation, was never changed. Later N63 variants improved on it incrementally, but the fundamental architecture remained. If you're looking at any N63 car, any 5 Series, 7 Series, X5 or X6 with this generation twin-turbo V8, get the full service history. Find out if it's been through the customer satisfaction program. Know the current oil consumption rate. Go in with that information or don't go in at all. The N47 diesel is the engine I would walk away from, and the reason is specific, structural, and not fixable by good maintenance habits. This is a 4-cylinder diesel that BMW put into almost their entire lineup for roughly 7 years. In European markets, the majority of BMWs sold during this period were diesel, and a massive percentage of those had the N47. So if you're shopping for a used 1 Series, 3 Series, or 5 Series from this generation, especially outside the United States, you are almost certainly looking at N47 cars, whether you know it or not. The issue is the timing chain and the way BMW positioned it. On virtually every other engine, the timing chain sits at the front, the end of the engine facing the radiator. It's accessible, it's serviceable, and when it starts to wear, you can hear it rattle and address it before anything breaks. On the N47, BMW mounted the timing chain at the rear of the engine, against the firewall. Nobody knows exactly why. The result is an engine where the single most critical wear component is in the least accessible location possible. When the N47 timing chain stretches or fails, there is no straightforward fix. You cannot pull a timing cover and replace it. The engine has to come completely out of the car. The subframe has to come down. Everything has to be disconnected and removed to access the rear of the engine. Labor on this job runs from $3,000 to $6,000 depending on the shop and market, for a repair that on any other engine would be a fraction of that. And here's what makes this genuinely dangerous rather than just expensive. The chain doesn't reliably warn you before it fails. On a typical engine, a worn timing chain rattles at startup. You hear it, you investigate, you fix it. On the N47, the chain has failed on cars where the owner reported no noise, no warning lights, no drivability issues, and then nothing. Chain goes, engine stops. In some cases, the chain breaks catastrophically enough to damage other internal components, turning a repair into a full engine replacement. There are documented N47 failures under 80,000 miles, under 60,000 miles. These are not high-mileage wear-out failures. These are engineering and manufacturing problems that BMW could not consistently predict or prevent. BMW acknowledged the problem and extended warranties on some N47 vehicles in some markets. Class action lawsuits were filed in multiple countries. Some owners were covered, many were not. The people who weren't found themselves facing a several $1,000 repair bill on a car worth less than the repair. There are good BMW diesels. The N57 six-cylinder diesel, for instance, has a strong reputation. The N47 is not in that category. If the car you're looking at has this engine, find a different car. The price will never be low enough to make the risk worth it. Here's the summary. S54, buy it, do the rod bearings, maintain it, and it holds up indefinitely. M54, the most reliable BMW engine of its generation, stay ahead of the cooling system and Vanos seals, and it runs forever. B58, the right answer in a modern BMW, BMW finally got the formula right. N54, capable engine, real ownership costs, go in knowing that and price the car accordingly. N63, significant risks around oil consumption and thermal management, full service history is non-negotiable before you buy. N47, avoid it. The timing chain failure is unpredictable, the repair is disproportionately expensive, and the risk isn't worth it at any price. The engine code is the single most important thing to look up before you buy any used BMW. Everything else, trim level, color, options package, is secondary. The engine tells you what the ownership experience is going to look like. Drop in the comments which engine or which specific model you want covered next, what to look for before you buy, what a fair price is, what questions to ask. That's the next videos.